All right, so we taught you how to take 2, 4, 6, 8, and write a sequence for that. We said u sub 0 equals 2, or we u sub 1, either way. U sub n minus 1 times, and then let's say we did this. This one's going up plus 2 each time, so I could just go plus 2. Okay, that's not a times, sorry, that's just a plus 2. I get it out of parentheses. And then we'd say n is going to be greater than or equal to 1, where that's always 1 bigger than that. Remember that. Now I need to tie this to the new stuff. The new stuff is an exponential. Exponentials are like exponential growth. Like where it goes to 2, and then it doubles to 4, and then it doubles to 8, and then it doubles to 16, dot, dot, dot. So that would be timesing not by 1. Timesing by 2. Now that could be thought of as 1 plus 1. That way you won't think it's 200% growth. It's 100% growth. Okay. Do you remember how to do that? Does that make sense? Okay. Now here's the thing. We're going to be talking about this in a whole different way now. We're talking about the same exact sequence, except talking about in terms of an equation where y equals blah, blah, blah with an x in it. Instead of having all this weird function notation, u sub n, u sub n minus 1. It's good to know that. It's called recursive notation. And you have to know it by state rules. One of the things they test you on in the MCA test. But this is more commonly used in the real world. And if I wanted to do this series, I would say, here's the number I start with. And I multiply it by, I bet you'll figure this out pretty quick, 1 plus 1. And then the only other thing I have to do is put it to a power. And what do you think the power should be? Not squared, nope, because then I wouldn't be able to get any other terms out of it. An x. So I've got a snappy little saying for you. An exponential has an x in the exponent. And so you can tell if you have an exponential. That an exponential has an x in the exponent. A lot of people just think something like this, y equals 3 to the 5th, but that's an exponential. It's not. There's no x in the exponent. That is just that's just a problem that you're going to go 3 to the 5th. That's not an exponential. Exponential growth requires an x in the exponent. All right, so now if you got that, you should be able to say, okay, starting value goes here. Whatever it grows by goes there. And this isn't that hard. This isn't the kind you can add for. This has to be multiplied, the geometric kind. So then let's talk about the moose population in Minnesota. All right, I'd like you to go do a Google search. It'll take you just about 2 seconds here. Go into your Google app or just through Safari if you want. But get into Google and type moose population MN. Moose population Minnesota. I'm going to pause for a second while you guys do that. Okay, so here we are. We found a spot on Reuters where it says Minnesota moose population plummets. Activists blame climate. Well, at least they weren't. At first, they were blaming the hunters, and then they realized, oh, I guess the hunters only took like 3% of the population, and so down 35% can't be the hunters. It must be something else. So apparently, they're blaming the climate. Well, I guess I don't want to make judgments about whether it's the climate or not. All I know for sure is that the moose population has gone down. In fact, if you compare to 2010, like over a couple of years ago, the moose population has declined by 52%. That's a lot. So, based on an aerial survey in January, the U.S. population estimate is 2,760 animals, down from 4,000 almost, or more than 4,000, and 8,000 in 2006. Actually, I was hearing that back, like in 2006, I was hearing from people that there were so many moose, it was actually causing problems up north in northern Minnesota. People were hitting moose on the road all the time, and it was like they were seeing moose everywhere. So there was this like spike in moose population, and now all of a sudden it's dropped off a lot. I mean, compared to 2006, they had 8,000, and now there's 2,000. That's a big drop. So what are some of the factors? It's not the hunters. The hunters take a small amount, but they have decided to stop hunting them for now because they've gone down so much. Got ideas? Yes. Interesting. So in North Dakota, the moose population is surging. So you think they're crossing the border? Thinking of Mike making a run for the border? It could be. What else you got? Yes, sir. Ah, there has been an increase in wolf population, enough that they have taken wolves off the endangered list. So we could blame the wolves. All right, what else you got? Yes. Okay. And I also heard there's some kind of a tick, a strange tick that is bothering them. You'd think these giant animals, which by the way would stand like way taller than I am, their shoulder would be way up here. They are big animals, and they get just like their population can be destroyed by a tiny little bug. Uh, these ticks, they can spread disease, and they also just like itch like crazy. So the moose, if you see them with, they got these ticks on them, they'll be like scraping on trees and stuff, trying to get them off because they just itch and they hurt, and you know you don't have fingers to pick them off with. Can you imagine that? Can you imagine you had a wood tick on you, and you didn't have fingers with fingertips, you know? All you have is like big club things, you know, hooves. You know, how do you get the stupid tick off of you? Can't do it. And besides, you can't even get your hoof up to your face. Anyway, so that's kind of annoying. So they have to scrape on things, and anyway, their population has dropped 35% since last year. So I wanted to make this real for you. So now, and also we know how many moose there are, and there currently are 2,760. So how would you write an equation for that? Y equals, what do I start with? 2,760, and then what? 1 plus 1 minus, very good. 3.5, it's dropping 35%, good. And then if this is going to be an exponential, we need an x in the exponent. All right, good. Now, this is one where we were given everything, all, nicely, gave us this, gave us that. Could we, like, stick in a number of years and find out how many moose are going to be? Yeah, but we don't know for sure if it's going to keep going at 35%. Didn't say it's been going at 35% every year. But you could make an educated guess. Say, well, let's just see if it did the same thing. I'd like you to do that right now. Use your calculator. And on the y equals, if you type this in, it will be a graph. And then you'll look at y equals 1, and you'll see where it is. You can look at the y equals 2. Sorry, x equals 1 would be after 1 year. All right, so let's put that in the y equals. I'm going to pause. Okay, I had some kids ask how to get it out of the other mode we were in. We were in sequence mode. You go into the mode button, which I have in red on the screen here, and then you arrow down to the 4th row, and you want to be in func mode, which in music would be a whole different thing. But here, it stands for function. All right, so I'm in function mode now. Now I go to y equals, and now I had some stuff in there I'm going to clear out. Clear it, here, clear it. And I'm going to go up here, and I'm going to put 2,700 and what? 60. And then I go parentheses 1 minus 0.35, end parentheses, to the power of x. And then I hit graph. Now my window is kind of weird, so I'd go to a zoom 6 if your window's kind of weird too. Negative moose? Are you serious? What does a negative moose look like? All right, I'm going to go to window, and let's think about this. X is time in years. Do we need negative time? No. Okay, so I'm going to go with 0 to start with. And then how many years? 10 years out ought to be good enough. Counting by ones, that sounds good. Y min. Y is how many moose we have. We need negative mooses? No. And then I'm going to go to Y max, like how many moose do I need? Well, 10 isn't going to be enough, is it? I'm starting with 2,700 and something, so now we go to 3,000. Now I can graph it. There we go. See the population crashing? It is. If it goes down at 35% per year, Pretty soon there'll be no moose left. But remember what they were telling us about how in North Dakota there's tons of moose. They're probably eating the oil. North Dakota's got this oil boom. Maybe they're not eating the oil, but anyway, they're apparently happy in North Dakota. So maybe it's because there's less people there. I don't know. But anyway, maybe this is just remember, they spiked in population. They went up to, it was as high as 8,000. Maybe there was like an unnaturally high number of moose, and now it's backing down to normal. Populations often do that. They'll go through cycles where there'll be like tons of deer, and then all of a sudden it crashes. Some things do that a lot, like grouse. Grouse population in Minnesota does that. That's a bird that a lot of hunters go for. Some years are huge. There's grouse everywhere, and there's other years there are like none left. And they go through cycles. High years down to low years, and then like 7-year cycle. It goes high to low. I don't think moose are like that, though. I think they're not supposed to be cycling like that. All right. So anyway, this is exponential decay. It's going down. And we hope, obviously, that it stops doing that. So they're trying to think of ways that they can help the moose population. But all right. That is an example of how this works. But I want you to look at the most simple cases of exponents. And that would be something like this. Y equals 2 to the x. I'd like you to compare these three graphs. 2 to the x, 3 to the x, and 4 to the x. I want you to graph those three on your calculator right now. 2 to the x, 2 to the power of x, 3 to the power of x, and 4 to the power of x. Now, once you've got them graphed, now, a window I have is not the greatest for this. I'm going to go to Zoom 6. Although, no, it's not that bad. It's showing me generally what they look like. I'll try Zoom 6 just to see the difference. Clearing, Zoom 6. Okay. There is only one point that all of the graphs go through. They share it. 0, 1. You're correct. There's one spot where all three graphs go through. I'm going to, if the graph would ever finish here, I don't know why it's not finished. I'm going to break it because it seems to be screwed up somehow. Graph one more time real quick. There's one of them. There's the second one. There's the third one. Okay. And just to save time, I'm not going to zoom in, but I think you can tell they're going through that spot, 0, 1. Look at these for a second and just think about it. At that spot, x is 0, right? Think about it. Think about it. Think about it. Do you get why it's always equaling 1? All right. So that's like time is 0, too. At time 0, it's like you always start with 1. Unless you change the starting value. Remember how we had this in a parentheses and we stuck a number out in front? Like if you wanted to start at 7, go like this. So this means starting with 7 and then doubling. This means starting with 7 and then tripling. This means starting with 7 and then quadrupling every year. All right. Let's actually start your homework. I think you know how to do it well enough from what we've been doing here together. So the first part of the homework is back to sequence mode, but let's find your homework first. It's on Schoology. I'm going to pause for a second while I find that. Okay. So here we go. 5.1. Consider this recursive sequence. Write down the first 5 terms of the sequence. I'd be fine with you doing this in sequence mode. I'd be fine with you being smart enough to do this as a y equals 2. That'd be fine. All right, but if you did the sequence mode or the other mode, either way, at the beginning, your first term is 2,500. No doubt about that. Then, when you stick in a 1 into the equation, that's the first term, you would take this and you'd times it by 1.06. So you really could just take 2,500 times by 1.06, couldn't you? Sure you could. And then you could just take that and times it by 1.06 to get the next number. So you really don't have to be in sequence mode. It's pretty easy. Yep, see F0, F of 0, that's like this. So the first number is 2,500. All right. Now, And it's the same exact thing as the first 5 terms of the sequence. The first term is 2,500. And then they're just asking to list them this way, or list them as, this term, comma, this term, comma, this term, comma, this term. I guess I'll do one more, comma, this term. All right, and if I wanted to write this as this exponential, just to make sure you get this, the exponential starts with the starting value, and you always have 1, and then it's plus if it's growth, 1 plus 0.06, and then you always have an x in the exponent. Isn't that easier than all this other gobbledygook? Exactly. Right now, we wanted you to learn that mode because, again, this is something that's on the state tests. You have to know sequence mode. It's also good for you to just see something in a completely different way than y equals x. That's the way we do so much math. It's almost always like this. So if you like this way, well, we're back to it. But we took a little break from it, learned this way, and math doesn't have to always be done as a big y equals something x equation. All right. Okay, so when they ask you to write an exponential, you write it like this, and this is always going to be the starting value. This is always going to be either growth or decay. If it's decay, that'll be a minus, and this will always be in years. You can just type it in. So if you're asking me how to put this in, except put like a 3 right here, if it were me, I'd look on my table. I'd put it in the y equals screen, and then I'd look on the table and see what 1, 2, and 3 are. Okay? But if you want to type it in, like type all of this exactly right here in, it'll work. Smarter way is to go to the y equals screen and then use the table to see what your points are. See what your, if x is 1, it's like this being 1. All right, there's one more I want to discuss with you that's further down on the worksheet. So I'm going to clear my ink here. Clear ink option there. Okay, I'm going to scroll up here, and a lot of people get stumped on this one, number 8. Would you please slide up to number 8 and let me help you start number 8? Some of you aren't sliding, so you're doing something else. Be with me. We're on number 8. Okay. On number 8, it says 3 years ago, Ms. Wiedela invested $10,000. Okay, so the starting amount was $10,000. Ha! I know this. Exponential y equals 10,000 times something. That's going to be easy. Her account is worth, wait a minute, her account's worth 10,000. Where the heck am I going to put 10,612? Use an exponential function to determine the annual percent growth. It's not even telling me what it grows by. What do I put in the parentheses there? How do you always start? 1. Is this growth or decay? Growth. So why did I put a plus for 1? Sorry. 1 plus for growth, and then what's the amount it grows by? Doesn't tell me. X. Now, does it tell me how many years she invested? So I could put that. That's a 3. Where the heck do I put the 10,612? The y. Because you can't put it here. That's where the growth rate is going to go. You can put it here, though. 10,612. 8. And then you solve that equation. Yeah, that's a nasty equation. I'll help you get started. You'd start by getting rid of the 10,000 from both sides. And then you'll have to get rid of this to the power of 3. Hopefully you'll remember to put it to the 1/3 power on both sides. And then the very last step will be subtract 1. All right, so I just wanted to walk you through that one, how to set it up. Now I have a few that you can skip. Felt like the worksheet was a little bit long today. So I'm going to allow you to skip a few. Watch. We're going to do that 1, 2, skip a few thing. It's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Skip a few. 15, 16. You may skip 15 and 16. And let's see if you can figure out the pattern that's going to happen. You can skip 21 and 22. Two capital no. And then 27 and 28. And 33 and 33. So the last two in each block seems a little bit overkill. Now, I know it's 3 pages, but it would have actually been 2 pages if this was a normal worksheet, and they would have been back to back. So it would have been a normal worksheet front and back. It wouldn't be that bad. It's just on an iPad, we have to add a lot of space. So that is not what you're supposed to be doing. Do the one that's for today's date. There's only one for today's date of 3/15. The ones we skipped were the last two in each block. So like here, 27 and 28, 21 and 22. I gotta move it over 15 and 16. Good idea? Okay. All right.